Welcome to this video on Analytic Epidemiology based on Chapter 7 of Introduction to Epidemiology by Merrill. This chapter shifts our focus from descriptive epidemiology, which answers who, where, and when, to analytic epidemiology, which asks the most critical questions, why and how. We'll explore different analytic study designs, learn how to measure associations, and discuss how bias and confounding can impact study validity. What is analytic epidemiology? Analytic epidemiology is used to test hypotheses about the cause of health outcomes. It seeks to identify risk factors, quantify association, determine whether a causal relationship exists between an exposure and a disease. The key difference from descriptive epidemiology is that analytic studies include comparison groups. These studies are the basis for evidence-based recommendations and policy decisions. Two types of analytic studies. There are two primary categories of analytic studies. The first is observational studies, where researchers observe relationships but do not manipulate exposure. The second is experimental studies, where researchers introduce an intervention to examine its effect. In this chapter, we'll focus on observational analytic studies, which include case control studies, cohort studies, case crossover and nested designs. Case control studies. The first design is the case control study. In a case control study, participants are selected based on disease status. Cases have the disease, controls do not. Researchers then look backward in time to determine exposure history. This design is especially useful for studying rare diseases, diseases with long latency periods, when the study needs to be fast and cost-effective. The primary measure of association is the odds ratio. Calculating the odds ratio tells us how much more likely the cases were exposed compared to the controls. If the odds ratio is greater than 1, it suggests a positive association. Equal to 1, it suggests no association. Less than 1, it may suggest a protective effect. A 2x2 table helps organize data and calculate the odds ratio. Example: if people with lung cancer were twice as likely to have smoked compared to those without lung cancer, the odds ratio would be approximately 2. Cohort studies. The second design is the cohort study. In a cohort study, participants are selected based on exposure status, not disease. The exposed and unexposed groups are then followed over time to see who develops the disease. There are two types. Prospective cohort follows subjects from the present into the future. Retrospective cohort uses historical data to track outcomes. Cohort studies are ideal for common exposures, studying multiple outcomes, estimating incidence and relative risk. Risk ratio and rate ratio cohort studies allow us to calculate two important measures. The first is the risk ratio, also known as the relative risk. This compares the probability of disease in the exposed group to that in the unexposed group. The second is the rate ratio, which uses person time to account for varying follow-up periods. These measures give insight into how strongly an exposure is linked to an outcome. A risk ratio greater than 1 suggests increased risk. A risk ratio less than 1 suggests decreased risk. Case crossover and nested case control studies. Two specialized designs include: first is the case crossover study. Each participant serves as their own control, comparing exposure right before disease onset to an earlier time. This design is useful for acute exposures and outcomes, such as triggers of heart attacks. Second is the nested case control study, which is embedded within a cohort. When a case arises, controls are selected from those still at risk. This is cost-effective and maintains temporal structure. Bias and confounding in analytic studies. All studies are vulnerable to bias and confounding. Common biases in case control studies include selection bias. Cases and controls are not comparable. Recall bias. Cases may remember exposures differently than controls. Interviewer bias. Differences in how questions are asked. In cohort studies, loss to follow-up and the healthy worker effect can skew results. Confounding occurs when a third factor is associated with both the exposure and the outcome. Strategies to address confounding include restriction, matching, stratification. Multivariable analysis. To summarize, analytic epidemiology helps us answer why and how diseases occur. The main study designs include case control and cohort studies. Key measures of association are the odds ratio, risk ratio, and rate ratio. Specialized designs like case crossover and nested case control offer flexibility. Reducing bias and controlling for confounding is essential for credible findings. Thanks for watching. Be sure to subscribe and join us in Chapter 8, where we explore experimental studies in epidemiology, including randomized controlled trials and ethics in research.